Hello, friends. Welcome back to MathsGenii, and this is Sanyukta Sharma. Now, today we're going to look at the chapter derivatives. But even before understanding what derivatives is, I would like to explain what slope is, and then how do you find a slope of a line, and how do you find a slope of a curve, and then eventually, using our prior knowledge of limits. Also, if you have not watched the limits video, please go watch that first and then come to this video. Now, I will be walking you through limits, and then using limits, how can you define derivatives. Then eventually we are going to look at algebra of derivatives, then how to derive derivative formula using limits, and then solved examples on each of the derivative formula. Now let's get started. Now, first, we will see how to find the slope of a line. So, this is your slope, for example. Okay, and I want to find the slope of this line. So, how do you find it? Is you take the x component, you take the y component. So, this is your delta x, this is your delta y. And how do you find the slope? Slope is nothing but delta y upon delta x. So, for example, this distance was say 20 and this distance was say 18. So, it would be 18 upon 20, giving you 9 upon 10. So, this is for the line. Okay, let's graphically see how do you find it for a line. Now, if you see here, uh, if I draw a triangle, okay. Now carefully see the points that I have plotted. I'll just zoom this. Okay. So this is 2 comma 4 plotted here, and the next point is 3 comma 6. Okay, which is plotted here. Now I want to find the slope. To find the slope, it's very easy, right? X component, Y component, this and this. Okay. So what will be the answer? Slope is what? Delta Y upon delta X. What is your delta Y? Delta Y upon, so this is this is 4, this is 6. So what is your delta Y? 6 minus 4. What is your delta X? This is 2, this is 3. So it is 3 minus 2. So it is 2. So the slope of this line is 2. The beauty of, now pay careful attention, the beauty of lines is the slope is constant throughout the line. So even if you find slope using this points, you will still get the slope as 2. If you find using this points, you will still get it as 2. So on the entire line, the slope remains constant. So what is the universal statement? The slope of any line remains constant along the line. For this entire line, the slope is going to be 2. This is the property of line. But then what happens when you come to the curves? When you come at curves, firstly, you cannot directly find a slope. You have to draw a tangent to the slope. So, this is your point now. Now, to find the slope of this point, you'll have to draw x component, y component, and then find it. Again, if you want to find a slope somewhere here, so you'll have to first draw a tangent, then x component, then y component. So for the entire curve, the slope does not remain the same. For line, what was the statement? The slope of line remains constant along the line. But is it the case for a curve? No. Now let's derive. Okay, let's derive. I think this is the moment you guys would be waiting for. Let's derive it quickly. So this is the same example we had taken the last time. Okay. Now, how did we calculate the slope? I'll just quickly write it here. How did we calculate the slope earlier? We took y gradient and then we took x gradient. So y was this 6, this 4, and then x was this 2 and this 3. Correct? This is how we calculated slope. Now, in order to derive, what I'm going to do is pay careful attention, okay? Pay careful attention. First, let's see how derivatives is defined. So this will keep aside. We'll come back to this after a minute. So we just saw that the slope of curve does not remain constant throughout. So to find the slope of any curve, we make use of derivatives. How is derivatives denoted? Even before starting derivatives, you should know. Okay. So what was the slope formula in line? The slope formula was delta y upon delta x. How is derivative represented? Dy upon dx, or or f dash of x. Suppose this function, any function is f of x. F of x could be sine x, cos x, log x, any function could be f of x. So derivative is denoted as f of x, okay, or f dash of x, or sometimes denoted as y dash. Okay, so this was how the derivative is denoted. Now let's come back here. So this was about the line. Let me draw a beautiful curve here. This is your axis and this is your, okay, this is your curve. Okay, my curve is not very good looking. Let me just draw it again. This is your curve. To find a point, so you will have to draw a tangent. At the tangent, you will have two components. This is the y component and this is the x component. Now, here also you had the same thing, right? This was your y component and this was your x component. So, drawing dot 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 lines till here, drawing dotted lines, this point, now I'm renaming. Suppose this point is your x naught. This point is x naught plus h. Okay, now 2 comma 4. So 4, if this is x naught, this is f of x naught. If this is x naught plus h, if this is x naught plus h, then this is f of x naught plus h. Okay, I'm copying the same notations for the curve. I'm drawing dotted line here. This is x naught. This is x naught plus h. And this, if this is x naught, this is f of x naught. If this is x naught plus h, this is f of x naught plus h. Now copy this. Slope 6 minus 4, which is 6 minus 4 is where? 6 minus 4. So f of x naught plus h minus f of x naught. 6 minus 4. Instead of this, I'm using this. So slope is equal to f of x naught plus h minus f of x naught upon, what is the next upon 3 minus 2? So 3 minus 2, x naught plus h minus x naught. So it's very clear that x naught gets cancelled and this is your slope. Okay, that is why it was important for me to first explain how line works and then using that how curve works. Now this is okay, this is fine, but you will ask me, where does limit come in picture? So the derivative is nothing but finding the instantaneous rate. Instantaneous rate means at that moment, at that instant. So for example, if I say I want to, if I'm coming very very close, if I'm coming very very close to this point that is tending to 0, I am tending to 0, and I want to find the rate at this point, this particular point, and this is very very close to 0. For example, it is 0.00001, very close to 0. That is when, that is when limit comes in picture, when you want to find the instantaneous rate and it's approaching very very close to 0. So limit h tends to 0, f of x naught plus h minus f of x naught upon h. Done. This is your definition of derivatives, that is f dash of x. This is what, nothing but derivative. So this is your definition of derivatives. I hope it is super clear for you guys. Okay, let's move ahead. So this is the definition is the same. Instead of x naught, I have a, but the definition remains the same. You can always, you can write x naught in place of this, no worries. Okay, f is a real valued function and a is the point. A is the point that lies in that domain. Then the derivative is defined as the one which we have defined. Now, I will just not talk. Let's just solve questions so that you'll understand better. So your question is, at x equal to 2 of f of x is equal to 3x. Okay, now let me, and it says find the derivative, find the derivative using first principle. First principle is nothing but the same formula that we just saw. Okay, now let me just write down the formula again. It was limit h tends to 0, f of x naught plus h minus f of x naught upon h. Okay, now carefully see what is your f of x naught. Let me just remove the naught here, or let me add naught in the question, does not matter. Okay, what is your f of x naught? It's already given, it's 3x. So I'm just copying it down. It's ready-made given, right? It's 3x. Then what is h? Is it given? No. So I'm copying it as it is. Now look at, then whenever you have this term, whenever you have this term, compare the brackets. Here you have x and here you have x plus h. So it's very simple. What I'm going to do is 3, and I'm just going to replace this bracket. So this is the function of x naught plus h. This was the function of only x. So you understood this, and this is given in the question or remains as it is. Only place where students get confused is replacing this bracket. That's so simple. Now another thing is replacing x naught value. So what is the x naught value given? 2. So wherever you have x naught, substitute 2. So let's just quickly do that. Simple. Now what will we do? Simplify. This will go to this, this will go to this. So this will be 3 2s are 6, 3h are 3h, 3 2s are 6 upon h plus 6 minus 6 gets cancelled. What remains is 3h upon h gets cancelled. What remains is 3. 3 is your answer. Okay, very simple. Let's move ahead. Let's move to one more question of first principle, so that first principle is like very, very clear to you guys. Okay. Again, the formula we will write first. It is limit h tends to 0, f of x plus h minus f of x upon h. As I always say, first write what you know. H is as it is because it's not mentioned here. Then f of x, it is given, right? F of x is given. So I'm writing f of x as it is. Now, what I told you is replace x with x plus h always. So, done. Your substitution is done. What remains is just simplification. Simplification is also very simple. Just pay careful attention. What I'm doing is I'm cross multiplying. Okay. Now, this h is troubling me. Let me just take it outside the bracket. Now we will cross multiply inside the bracket. Okay. X into 1 x minus x plus h into 1 x plus h. Then x into x plus h. Okay, we have just cross multiplied. Now when you open the bracket, plus x minus x is going to get cancelled. What you have outside is 1 upon h. What you have inside is the minus sign and h. Then you have x into x plus h. Plus h minus h gets cancelled. What remains is now you will have to substitute this h is equal to 0 inside the bracket. What remains is minus 1, x as it is, x as it is, plus h is equal to 0, substituting that. So your answer to this question is minus 1 upon x into x, x square. So this is how you solve the question using the first principle or the formula that we have used for deriving derivatives. Okay, let's move ahead. Before going to the formula, let's look at the algebra of derivatives. Now in limits, the algebra says that everything is distributed. There is no formula for multiplication and there is no formula for division. But in derivatives, it's not the case. Addition is very simple. If you have addition of two terms, then derivative will go to this term also, this term also. But for product, we have one formula. It is the derivative of the first function. So fg is nothing but functions. F could be cos x into g could be x square. Both are x and both are in multiplication. Correct? So it is the derivative of the first function, which is derivative of this function into second function as it is, plus derivative of this function into this function as it is. However confusing this might sound, but once you look at the questions, it is supremely simple. Okay. Now quotient rule. Similarly, the same example, if you have anything in upon, for example, you had 1 sine x and you had log x. So both are in x and are in division. So you use this formula. Okay. Now you have something called as the product rule is the same. Instead of f you have u and instead of g you have v. So we are going to use this formula extensively. And we are going to solve 2-3 questions on this, so that this is going to be super simple. So I'm not wasting my time making you understand how the formula came, because we are going to solve it very soon. Let's move ahead with the formulae. The first formula is x raised to n derivative. So derivative is denoted as a dash. I'll tell you one quick example to how to use this formula. For example, you had x raised to 4. Okay, so n in this case is 4. What is the formula? Nx raised to n minus 1. N x raised to n minus 1. So your formula, your answer would have been 4x cube. So for each of this, you have similar applications. I'll explain this one also. A raised to x. So a can be any constant, any number, any alphabet, any constant. So for example, your a was 10 and 10 raised to x. You had to find the derivative of this. How would you find this? Using the formula. But the formula says a raised to x. So a raised to x as it is into log a. Log 10. Very simple. E raised to x derivative is e raised to x only, does not change. Log of to the base a, it generally does not appear, but if it does, it's same as ln of x. We use this formula when nothing is given in the if we assume that it is going to be natural logarithm, which is e. So 1 upon x is the commonly used formula. Unless they give something at the base, then only we are going to use this formula, but otherwise the commonly used formula is 1 upon x. Then what is the derivative of sine x? It is cos x. Then cos x is sine minus sine x. So how to remember this very quickly is write it the way it is written on the screen. Sine cos, tan cot, sec cosec. Everything on the left side is positive and everything on the right side is negative. So that is how maybe you can remember the formula. Okay, now let's get to the questions so that each formula is very clear to you. I have tried to occupy different type of questions. Okay, now let's look at this question. 6 is constant. You have to find the derivative. 6 is constant, so I'm not going to touch it. This is of the form x raised to n. What is the formula of x raised to n? What is the formula of x raised to n? It is nx raised to n minus 1. So in this case, your n is 100. X raised to n minus 1 minus, again, this is of the form x raised to n is 55. And the derivative of x is 1 always. Derivative of x is 1. Okay. Now, simple. 6 into 100, 600. 100 minus 1, 99. 55 minus 1, 54. Plus 1. That's it. That is your answer. It was extremely simple, right? Now let's move ahead to the next question. Let me just explain how will you use u into v, which was the product rule. Okay, let's take one question on product rule. You have to find the derivative of x raised to 4 5 sine x minus 3 cos x. Okay, you have to find the derivative of this. First, even before doing anything, let's just open the brackets. This will go to this and this will go to this. So x raised to 4 5 sine x minus sine x raised to 4 3 cos x. Clear? Now what did I tell you when I was explaining the u into v rule? That for both the functions should be function of x. This has x, this has x. So this is u into v. So this is going to be your u and this is going to be your v. Similarly, this is u, this is v. Now let's just write the formula. The formula, the derivative. The derivative of u into v is what? U dash v plus v dash u. Okay? Dash means derivative. So derivative of u, so derivative of x raised to 4 is nothing but how will you find it? Nx raised to n minus 1. So 4 minus 1 is what? 3. Okay, then into v as it is. So what is v? 5 sine x. Okay, plus sign in between. Then you have v dash. So what is v dash? 5 is constant as it is. What is v dash? What is the derivative of sine? Derivative of sine is what? Cos. We just saw in the table, right? Into u as it is. U is x raised to 4. Now this bracket is complete. Then you have a minus sign. Then again, you will look at this x raised to 4 into 3 cos x. So x raised to 4 is your u, correct? Let's take this 3 outside. Let's take this 3 outside. Okay, x raised to 4 is your u. What is the derivative of x raised to 4? 4x cube into v as it is, so cos x as it is, plus v dash. What is the derivative of cos? Cos derivative is minus sine, into u as it is. What was u? X raised to 4. And then you can always simplify further. You can always simplify this further. So this is how you can you use the u dash v plus v dash u, which is the product formula. If the product rule is, I hope the product rule is very clear, then only I can move to the quotient rule. Quotient rule was what? U upon v. Let's take one example. So if you had d by dx of x square plus 1 upon x plus 1. So this is in x, so this is u and this is v. So you have u upon v. You will have to use the u upon v formula. What is that formula? It says u dash of v minus. So you go here, you see u dash of v plus. But if you go here, you have u dash v minus. Then it remains the same. V dash u, here also you have v dash u upon v square. So there you had plus, here you have minus, and upon v square. This is the derivative formula. Now let's just apply it. U dash v. So d by dx of u dash. So what is u? Into what is v? Minus. What is v dash? V dash means derivative of v, into u as it is. u was what? X square plus 1 upon v square. So x plus 1 square. Okay, so this is what you have. Now what remains is just to solve. What is the derivative of x square? Nx raised to n minus 1, right? Nx raised to n minus 1. So 2x raised to 2 minus 1, which is 2 2 minus 1 is 1. So the derivative of x square is 2x. Derivative of 1 is what? Derivative of 1 is 0. Anything plus 0 is that number itself, hence I'm not writing. Derivative of 1 is 0. Derivative of any constant number. Derivative of 2 is 0. Derivative of 100 is 0. Derivative of any constant number is 0. Into x plus 1 as it is, minus the next derivative. Derivative of x is 1 plus derivative of 1 is 0, and then this is as it is upon this is as it is. Now you can always solve further and take out the answer. It's that simple. So my main intention was to make you understand how to use this formula. Let's take one more example so that it's going to be super clear for you on how to use this formula. D by dx of 10 raised to x upon sine x. This is u, this is v. The formula says, let's just quickly write the formula. The formula says u dash v minus uv dash upon v square. Okay. Now I'll just quickly write If you wanted to find the derivative of 10 raised to x, you will use the formula a raised to x log a. It is the formula of a raised to x. Okay. Here in place of a, you have 10. So it's going to be what? It's going to be 10 raised to x log 10. So the derivative of this is this. Then what is the derivative of sine x? Derivative of sine x is nothing but cos x. That's it. That is what you need to know for this question. Let's resolve. U dash. U dash. What is your u? 10x. 10 raised to x. U dash is this. This is u dash. And this is v dash. Sin x derivative is cos x. So cos x is v dash. So u dash is 10x log 10 into v. V is sin x minus u. U is what? 10 raised to x into v dash. What is v dash? Derivative of sin x. It is cos x upon v square, which is sine square x. Let's just solve this completely. Now derivative is over. Now whatever is remaining is just simplification. So how can we simplify this further is this sine square x will go to both. Okay, this sine square x will go to both these parties. Instead of sine square x, can I write sin x into sin x? This is just for the ease of your understanding. Okay, this sin x gets cancelled. So what remains here is 10 raised to x into log 10 into 1 upon sin x. What is remaining is 1 upon sin x. Okay, nothing means 1 upon sin x. What is 1 upon sin x? Cosec x minus. Here, look at this bracket. 10 raised to x as it is. Cos upon sine. Cos upon sine gives me what? And then 1 upon sine x gives me what? Cos upon sine gives me cot. And 1 upon sine gives me cosec. Now from this bracket, what can I take common? This and this term is common. So can I take this common terms? And then what remains is log 10 minus cot x. That's it. That is how you use u upon v. We took two examples. We saw u into v, u upon v, and how to derive using limits. So thank you, class, and keep practicing. As much as you practice, you will gain more command over this topic. Thank you. See you in the next video.